Everyone thought Tesla was the company changing the future of cars. While headlines kept chasing Elon Musk, another company was growing quietly in the background. No drama, no massive hype, no celebrity CEO, just factories. Endless factories. And inside them, something was happening that almost nobody outside China fully understood. Because BYD wasn't just building electric cars, it was building its own batteries, its own motors, its own software, and even its own hybrid engines inside massive automated facilities that looked more like futuristic machine cities than car factories. And the strange part, the company making some of the world's most successful EVs was secretly betting huge money on hybrid technology at the exact moment. Everyone else was trying to abandon petrol completely. At first, that decision made no sense. Why would a company leading the EV boom spend billions developing petrol engines? Why build giant powertrain factories when the world kept saying internal combustion was dying? That question becomes even more uncomfortable once you see what BYD built next, because hidden across China, in places like Shenzhen, Shan, Zhengzhou, Changsha, and Hufei, BYD created an industrial system so large and so vertically integrated that competitors started realizing this wasn't just another car manufacturer anymore, it was becoming something much bigger. Some of these factories are so massive, they almost feel unreal. Entire sections operate 24 hours a day. Robots move non-stop across assembly lines. AI systems scan components in real time. Engines, batteries, motors, and gearboxes are produced almost side by side under the same ecosystem. Most automakers don't work like this. Normally, one company buys batteries from somewhere else, engines from another supplier, electronics from another country. A single disruption can slow down the entire production chain, but BYD wanted control over everything, and that decision changed the economics of hybrid vehicles completely inside BYD's factories. Raw, aluminum, and steel enter one side of the plant. A finished hybrid powertrain leaves the other side. The company controls battery production, electric motor manufacturing, software systems, transmission assembly, and final integration almost entirely by itself. That level of control means faster scaling, lower costs, and fewer supply chain problems. But the real surprise wasn't the factories, it was the engine. At first glance, BYD's 1.5-liter Xiaoyun engine doesn't sound revolutionary. Small engine, small displacement, nothing flashy. In another era, nobody would pay attention to it. But BYD designed it differently. Traditional hybrids, especially older systems, still depend heavily on the petrol engine. The engine does most of the work while the electric motor assists occasionally. BYD flipped that idea upside down in its DMI system. The electric motor comes first. The car behaves like an EV most of the time. Silent acceleration, instant torque, smooth driving in traffic. The petrol engine often stays invisible in the background, turning on mainly to generate electricity or assist during longer trips. And suddenly, something interesting started happening. Drivers began getting the EV experience. Without the biggest EV problem, range anxiety. People could drive through cities almost entirely on electric power, then continue long highway trips without searching for chargers. Fuel consumption stayed extremely low. In some conditions, drivers reported ranges that sounded almost unrealistic. That's when competitors started paying attention, because this wasn't just a hybrid anymore. It was a bridge between two worlds. And this is where the story starts to get uncomfortable for competitors, while many automakers were locked into one direction, either fully electric or traditional hybrid. BYD positioned itself directly in the middle. That middle ground turned out to be incredibly powerful, especially in developing markets where charging infrastructure still isn't reliable. In cities with weak charging networks, people still wanted the smoothness of electric driving. They wanted lower fuel costs, but they also wanted the security of petrol backup. BYD gave them both, and demand exploded faster than many analysts expected. Inside the Guangzhou megafactory, production lines began moving at incredible speed. In some sections, a new vehicle rolled out every 30 to 60 seconds. Robotic arms installed battery packs with almost surgical precision. Automated systems checked vibration levels, fuel efficiency, electrical performance, and software calibration before a vehicle could move forward. Some reports claimed automation levels inside certain BYD plants reached nearly 97%. That number matters for one reason. Consistency. Hybrid systems are extremely sensitive machines. The engine, electric motor, inverter, battery, and gearbox all need perfect synchronization. Even small manufacturing errors can affect efficiency or reliability. Robots don't get tired. AI systems don't lose focus, and BYD leaned heavily into both. The company also introduced digital twin systems, virtual factory simulations that test production processes before physical manufacturing even begins. Problems are predicted digitally before they happen in real life. That saves time, but more importantly, it allows BYD to scale at frightening speed, and scale became the company's biggest weapon. By 2025, BYD was producing millions of new energy vehicles annually. In some periods, hybrid sales even began outperforming pure EV sales inside certain segments. That shift surprised a lot of people, because for years, the industry conversation sounded simple. Electric cars would replace everything else. But reality turned out to be more complicated. Charging infrastructure expanded slower in many countries. Electricity prices fluctuated. Consumers in developing regions wanted flexibility. Long-distance drivers still worried about charging access. And suddenly, BYD's strategy didn't look outdated. Anymore, it looked practical. The company started expanding aggressively outside China. New factories appeared in Brazil, Thailand, Uzbekistan, Hungary, and Turkey. Local assembly operations grew quickly. Governments began paying attention because BYD wasn't arriving as a small startup anymore. It was arriving with manufacturing scale that rivaled some of the biggest names in the industry. Still, one major dependency. Most of the core hybrid systems still came from China. The advanced power, the batteries, the integrated systems, much of the technological heart of BYD vehicles still relied on Chinese megafactories operating at enormous scale. That creates both strength and vulnerability, because the more BYD grows internationally, the more pressure it faces from supply chain politics, trade restrictions, battery material shortages, and geopolitical tension. Lithium prices rise. Export controls change. Governments push for domestic manufacturing. Competitors lobby aggressively, and the bigger BYD becomes, the harder it becomes to stay invisible. But BYD seems prepared for that too. The company has already started investing deeper into battery recycling, local supplier networks, mining partnerships, and regional manufacturing expansion. Future DMI generations are expected to improve efficiency even further, with longer ranges, smarter software management, and stronger AI-based energy systems. And this may be the most important part of the entire story. BYD never fully committed to just one. Future Tesla pushed aggressively toward full EV adoption. Toyota stayed loyal to conventional hybrids. BYD quietly built a system capable of operating between both worlds at the same time, and in many parts of the world, that strategy may actually make more sense right now, because the future of transportation may not belong to the company with the fastest electric car. It may belong to the company that understood something earlier than everyone else. That most people don't transition into the future all at once. They move toward it gradually. And BYD built an entire empire around that idea. The strange thing is, BYD's rise didn't happen because the company built the most exciting cars. It happened because BYD solved problems most automakers were still arguing about. While competitors debated whether hybrids were temporary or whether EV charging networks would mature fast enough, BYD focused on something simpler: make the car practical. First, that philosophy shaped everything inside the company's factories. Even the way the engines are built feels different from traditional automakers. Deep inside BYD's production facilities, molten aluminum is poured into casting molds where engine blocks begin taking shape. Massive forging machines compress metal under enormous pressure to strengthen internal components before they move toward CNC machining stations. Their computer-controlled tools carve cylinders with microscopic precision. Every piston, every crankshaft, every cooling channel, everything is measured because hybrid Systems demand timing accuracy that older petrol vehicles could sometimes tolerate without issue. Then comes the part most people never see. The engine alone is not the real product. The real product is the integration. BYDs. Engineers combine the Xiaoyun engine with electric motors, inverters, controllers, reduction gear systems, and battery packs into one tightly connected powertrain ecosystem. That integration changes the driving experience completely. In city traffic, the vehicle feels almost fully electric. Quiet, smooth, immediate acceleration. No gear shifts interrupting the flow, but somewhere in the background, software is constantly making decisions. Should the battery power the car alone? Should the engine quietly generate electricity? Should both systems combine for sudden acceleration? The driver barely notices the transitions, and that invisible balancing act is where BYD became dangerous.